Now, this only works if you don't have a number that's in front of your square root, that normal movement. So let's look at an example where we do have a number out front, that a value. So we've got y equals -2 times the square root of x plus 3 minus 1. Our transformation's here. The negative out front means we're going to reflect. The 2 means we're going to stretch by 2. The plus 3 means we're going to the left 3 units. And the minus 1 means we're going down 1 unit. This left 3 and down 1, those help us figure out our new starting point. So from the origin, we're going to go to the left 3 and down 1. That is our new starting point. -3, -1. Then, since we have this 2 out front, this -2, that's what's gonna affect our movement. So as I've mentioned before, our normal movement, we go to the right 1, up 1, right 4, up 2, 9, 3, 16, 4, so on and so forth. This -2 out front is gonna change our up movement. So our right movement's not gonna change. That's still gonna be 1, 4, 9, and 16. But now instead of going up 1, and up 2, and up 3, and up 4, we're gonna multiply all of these numbers by whatever is out front. So here I'm gonna multiply all of these numbers by -2. So now I'm gonna go to the right 1 from my starting point, and then it says up, but we multiply by a negative, so we can go down 2. Then I'm gonna go to the right 4, and down 2 times 2 is 4. I'm going to go to the right 9 and down 3 times 2 is 6. I'm going down because it was negative. If this wasn't a -2, I'd still be going up. Then I'm going to the right 16 and down 8. So let's do that. We're going to the right 1 and down 2. We're going from our starting point, we're going to the right 4 and down 4. Back to our starting point, go to the right 9 and down 6. 4, 5, 6. And then we would also go to the right 16, but I already know there's not enough room for that. If we did go to the right 16, we'd be going down 8. And now we can connect our dots. Notice here that our graph looks a little bit taller than previous graphs that we've done because that 2. That gave us that vertical stretch of 2. Now our domain is from left to right. The farthest to the left that we have is -3. And our arrow is pointing to the right forever. The range is from low to high. This time, since our graph was reflected, since it was flipped over, now our arrow is pointing downward. So for our range, we're starting at -infinity. And then the highest that it gets is at a y value of -1. So there's our range. Okay, let's do one more. We have a compression by 2/3. We're not adding or subtracting anything on the inside of our radical, so there's no left or right shift. And then outside of it, we have up 3. That +3 means we're going up by 3. So since we didn't go to the left or right any, our new starting point is at 0, 3. So let's go ahead and plot that. There's our new starting point. Now once again, this number that's in front of our radical, that's what we're going to multiply all of our up movement values by. So we're going to the right 1, and this time we're going up because this is a positive number out front. The only reason we went down last time was because it was negative. So we're going up by, and then 1 times 2/3 is just 2/3. Then we're going to the right 4 and up by 4/3. We'll go to the right 9 and up by 2. So we're going to the right 1 and up 2/3. We're going to kind of guess where that 2/3 ends up on our graph. We know it's like a little bit more than half. So it's going to go somewhere around there. Then we go to the right 4 and up 4/3, which is the same as 1 and 1/3, so a little bit more than 1 up. Then to the right 9 and up 2, and that is all that I have room for on my graph. Now notice here, our graph is really, really, really flat. That's because of that compression. Domain Left to right, we've got 0 to infinity. Range, low to high, we've got 3 to infinity. And that is how we graph the square root function. Make sure you know those normal movements and you know when to multiply your up movements.